আসসালামু আলাইকুম সুপ্রিয় ফেসবুক বন্ধুরা, আমি মোহাম্মদ গিয়াসউদ্দিন বলছি। আমি মূলত পদার্থবিজ্ঞানের ক্লাস নিয়ে থাকি, সাথে সাথে গণিত, কেমিস্ট্রি এবং ইংলিশ ও বাংলা বিষয় বলে থাকি। তো আজকে আমি গণিত নিয়ে, ফিজিক্সের গণিত নিয়ে কথা বলবো। তো যেহেতু আমরা জানি আমাদের দুটি অধ্যায় রয়েছে, ফার্স্ট পার্ট, সেকেন্ড পার্ট। ফিজিক্স প্রথম পত্র, ফিজিক্স দ্বিতীয় পত্র। আমরা জানিও 1 থেকে 10 পর্যন্ত ফিজিক্সের প্রথম পত্রের চ্যাপ্টার গুলো, আর দ্বিতীয় পত্রে 11টার মতো চ্যাপ্টার রয়েছে। তো আমরা যদি প্রতি চ্যাপ্টার থেকে একটা ম্যাথ করি, তাহলে আমাদের 20 থেকে 21টি ম্যাথ করতে হচ্ছে 2025 সালের জন্য। এদিকে শর্ট সিলেবাসের বিষয়টা যদি আমরা চিন্তা করি, সেক্ষেত্রে আমাদের কিছু কিছু ম্যাথ কম করা লাগতে পারে। তো বলবো আমি আজকে বলবো প্রতিটি চ্যাপ্টার থেকে একটি একটি করে ম্যাথ করবো। তো আমি মূলত উদ্দীপকটা দিব এবং সি প্রশ্নের এই যে ম্যাথটি রয়েছে, গাণিতিক সমস্যাটি রয়েছে, শুধুমাত্র সূত্র ব্যবহার করে আমরা এই সমাধান করতে পারি। আমি সেই প্রয়াসটি আমি চেষ্টা করব আর দেখাতে ট্রাই করবো। তো আমি চাচ্ছি যে আমার যে ভিডিও টিউটোরিয়ালে দেওয়া হচ্ছে, যদি আপনাদের কাজে আসে, ভালো লাগে, আপনারা লাইক দিয়ে, কমেন্ট দিয়ে, শেয়ার করে আমাকে অনুপ্রাণিত করুন। আমি যাতে আরো বেশি বেশি এরকম ভিডিও টিউটোরিয়াল বানাতে পারি, নিজে করতে পারি, আপনাদেরকেও জানাতে, বোঝাতে সহায়তা করতে পারি। মূলত নিজেকে জানানো হচ্ছে আমার প্রাইম কনসার্ন। তারপর আপনাদের যদি ভালো লাগা থাকে এবং সেটি থেকে কোনো উপকার পেয়ে থাকেন বা আপনার যদি কাজে লেগে থাকে, সেটি শুনলে আমি মুগ্ধ হব, আনন্দিত হব। আমাকে কাইন্ডলি লাইক, কমেন্ট, শেয়ার করবেন এবং উৎসাহিত করবেন। ফলশ্রুতিতে আমি আরো বেশি বেশি কাজ করতে পারবো, টিউটোরিয়াল করতে পারবো। ধন্যবাদ স্যার। Assalamu alaikum guys. This is Mohammad Gashuddin. Today I'll discuss about this mathematics. It's electronics mathematics, and try to read the stem and fast and observe the circuit very shortly. Guys, I have written this question here. A common emitter NPN amplifier circuit is shown in the step. The dynamic resistance of the circuit is 40 ohm. Its time gain is 75. Time gain is 75, and the load resistance of the circuit 60 ohm. And collector current is 5 milliampere. This is the circuit, and this is actually NPN transistor. Is base current, IE, emitter current, IC, collector current. And collector current IC is given here. Okay, whose value is 5 milliampere, guys. And this is VB cell, and this is VC battery. It's minus sign, it's plus sign, it's minus sign, it's plus sign. And this is the direction of IE, emitter current, and this is the direction of IC, collector current. This is the IB, base current, and this is NPN circuit. This outer sign means NPN transistor, and this is common emitter transistor. The IE here is common due to IB and IC. Guys, 60 load resistance, and IC as given here. Guys, we have to know three formula here. I have written here, but I want to delete and write again. This alpha equal to IC over IB, IE equal to IC plus IB, beta equal to IC over IB. These three formula we have to remember for doing the method, and this C question answer solution. Okay, find the current amplification factor of the circuit of this. Current amplification factor I have to find out, and this formula alpha equal to IC over IE. Here alpha is current amplification factor, okay, of the circuit. This we have to find out. How can we find out? Actually, this formula is alpha equal to IC over I. I is collector current here. Collector current has been given in this circuit 5 milliampere, but we don't know the value of IE. We have to find out this. For finding out this IE, we have to use IE equal to IC plus IB formula. But we don't know the value of IB. For finding the IB, we will apply this formula beta equal to IC over IB, because the current beta is current gain. Beta is current gain, which has given here. This current gain is 75. We will apply this value and we will find out IB. The question has asked us to find out the current amplification factor. Guys, current amplification factor formula is alpha equal to IC over IE. But we don't know the value of IE because circuit hasn't given that IE. For finding out the IE, we have to know a formula, which is IE equal to IC plus IB. But we don't know the formula. We don't know the value of IB. We have to find out IB from this formula. IB means IC over beta. Okay. That means this formula we have to make. Which formula? Beta equal to IB formula. By this formula, we will find out IB formula. Then we will put here and we will get I, and finally we will put I here below. Then we will get current application factor. This line we have to remember. How can we do this? Actually, we have to find out IB. Here, IB equal to IC over beta. Here, the current gain is 75. Beta is current gain. IC this 5 milliampere. Okay, 5 and current gain means 75. Okay, if we do this by calculator, we will get 5 over 75. That means 0.06 milliampere. We will put here 0.6 very good. Then we will get IE. Actually, 5 milliampere for IC and IB just now we got 0.06 milliampere. Total, what is the value? Total 5.06 milliampere. Okay, this is I we have found that water just now. Look, current we have to find the current amplification alpha equal to IC over I, and IC the circuit has given 5 milliampere, but we haven't I value. We have found by these two formulas. Okay, the value of IE 5.05. Now we can put this one. IC means 5 milliampere, and IE means 5.06 milliampere. Guys, let me cancel. If we do this by calculator, then we can see what's the value. 5 over 5.06 is the value. The value point 0.98 milliampere. This is our area, and this is current amplification factor. Guys, this is actually big. We can do this method in short. How can we do this? By this way, if you want to solve this problem, you have to remember beta equal to IC over IB, IE equal to IC plus IB, alpha equal to IC over IE. Guys, our question has given us some IC value 5 milliampere and current gain beta value 70. Okay, and by this formula IE equal to IC plus IE, we found IE, and putting here we have got current amplification factor. But you can do this mathematics in very simple way by remembering only one formula, which is like this: alpha equal to beta 1 plus beta. Okay, by this formula we can solve this formula. Okay, current gain is 75. Current gain 75 means beta. Okay, just you can do this by this question. 75 1 plus 75. That means 75 denominator 76. If you do this the calculator, then you can get the value 75 over 76 is the value. Value is of nice 0.9 0.98 million. Sorry, no unit. Current regulation will not. But okay, by just online you can do this mathematics rather than doing like this way. Stem common emitter amplifier circuit is shown in the stem. The dynamic resistance of the circuit 40 ohm. Its current gain is 75. The load resistance of RL is 60 ohm and collector current 5 milliampere. This is the circuit, and we have done this mathematics. Yes. Assalamu alaikum, guys. This is our second mathematics, atomic model and nuclear physics related mathematics. Okay, guys, this stem and this picture actually is not necessary for doing mathematics. Simply, the stem has given us the mean life 2294. Yeah, this mean life we will need. Okay, for doing this C question, guys. Question has given us this picture. What do you mean by this picture? This is actually decay curve, okay, and this along x direction, this y direction. Along x direction you have taken time, along y direction you have taken the number of atom, and this n naught means initial number of atom, and decaying like this way that atom at first at the half life it has got half of this 0.5 0.5. Again it becomes half of this 0.5. Half means 0.25 not. Again this half of this 0.125 not. Okay, consecutively it is decay, and this is the decay curve. Guys, this T half life, this double T half life, this triple half life. Okay, and initial number of atom and not then 0.5 and not. Actually, this data are not is not necessary for doing mathematics. Find the half life of the atom. Okay, this step is our step has given mean life is 2294. Yeah, guys, we have to find out half life. We have to find out half life. How can we find out the half life? Actually, we have to know the formula. What is the formula? We know T half life. This is half life sign. Typical letter of use. Okay, 0.693, 0.693. This is the sign of mean life of that atom, and it has been given here. So here mean life this sign 2294. Yeah. Okay, mean life has been given. Okay, now we have to find out the half life. Half life T half life into what? We have to find out. Okay, guys, since we know this formula, T equal to T half equal to 0.693 tau is the mean life. So simply we can do this mathematics by putting the value of mean life. Okay, 0.0693 mean life value 2294. Okay, if you do this by calculator, you will get the answer. What will be the answer? Just let me check this point. 693 multiple 2294. What's the value? The value is uh, 15 1589, sorry, 89.74. What will be the unit? Unit is here. Guys, we have got the answer for C. Very simple. But this data is not necessary for doing mathematics C. For doing mathematics C, D, that will use this information. Guys, I am doing just mathematics C. I am giving the answer only for C. Guys, again I said relative decay of a radioactive atom X has been shown in the figure of the step. The mean life is 2294 years. Find out half-life of the atom X described in the step. This is step and this is the figure. This figure is not necessary and I have explained this. But does still the mean not qualify T half, double T half, triple T half. This is the X direction, the Y direction. Along Y direction, number of atoms is just this data is not necessary for doing mathematics. Okay, we know the formula. What is the formula? And this is P half equal to 0.693. We have to remember this. Okay, if you forget this, you can do mathematics. This is the correlation between half-life and mean life. And so the coefficient is 0.693. Since a question has given us mean life 2294 years, that's why simply putting the value in this formula, we can find out the half-life. Here, half-life 1589.7 years. That's it. Assalamu alaikum, dear Facebook friend. This is Mohammad Biashudin. Today I'll discuss about hard number mathematics, and which is related to beginning of modern physics. Okay, and Stan has said just like this way: in an experiment of photoelectric effect is observed when light of wave land 4,400 Armstrong is incident on a potassium metal. Only electrons are emitted, but no kinetic energy is gained. If the light wavelength 1,500 Armstrong is incident, then electrons are emitted and also kinetic energy is gained. Guys, question has asked us to find out the work function of the potassium. We have to find out this, and for this mark is okay, guys. We have to find out work function, and so this is 4,400 Armstrong is the wavelength of the light, and it's a potassium. Okay, when this wavelength based light is incident on the sodium, then only electrons are emitted, but no kinetic energy is gained. That means we have to find out work function. How can we find out work function? For finding out the work function, we have to know the formula of work function. Guys, work function formula equal to, we know W equal to HF naught. HF naught. Okay. Sometimes we write like this way for meaning the work function. Guys, for finding out the work function, we have to know the value of H. This is Planck constant and is a threshold frequency F naught. That it hasn't given in the step. Step has given 4,400 constant wavelength of the light. Okay, from wavelength we may find out the F naught. But for this reason, we have to know another formula, guys, which is like this: H C over lambda. Yeah, F equal to C over lambda. This formula we know because during our SSC class we got this formula. This F naught means frequency. Here, threshold frequency. That's here frequency is threshold frequency, which is Planck constant and lambda is wavelength, which has been given in the step 4,400 Armstrong. Right, this is the unit of meter Armstrong, and you have to know the value 10 to the power 10 meter. Okay, guys, our formula is W naught into H C over lambda. That's why you have to know lambda, you have to know C. C is the light velocity, H is the Planck constant, lambda is the wavelength. Here given, yeah, uh, given that given that lambda over 4,400 Armstrong. That means 4,400 into 10 to the power 10 meter. Okay, this is wavelength. And C was the value of C. C equal to 3 into 10 to the power 8 meter per second. 8 meter per second. That's and what's the value of Planck constant? Planck constant H equal to uh, H equal to 6.63 into 10 to the power minus 34 joule second. Nice. Right. We have got a Planck constant value 6.63 into 10 to the power and we have got the velocity change light 3 into 10 to the 8 meter per second and we've got wavelength of the light which is incident on the potassium. Guys, now just the value 6 into 6.63 into 10 to the power minus 34 and 3 into 10 to the power 8 and lambda value is 400 into 10 to the power minus 10. If we do this calculator, we will get the value. What will be the value? Okay, nice. Let me do this by calculator. 6.63 into 10 to the power minus 34 into 3 into 10 to the power 8 over 4400 into 10 to the power minus 10. Okay, result will be 4.52. 4.52 10 to the power minus 19. 4.52. Result is 4.52. 4.52 into 10 to the power minus 19 joule. Okay, this is minus 19 joule. It is a work function W naught. Here, work function. This is the wavelength of the light, and it's a sodium. And there, if you think here, electron, this electron is emitted. Okay, and which is emitted for work function W naught. Guys, and the result of W naught 4.52 into 10 to the power minus 19. It is based on joule unit. If we convert this PV unit, then we have to divide it by 1.6 into 10 to the power minus 19 joule. Okay, joule will cancel electron volt. Sorry, electron volt. We will find electron volt. If we do this by calculator, we will get uh, what we will get 4.52 over 1.6. That means 2.82. 2.82 electron volt. This is our result. Nice. We have to find out the work function of the potassium. And work function formula W equal to HF naught. And F means C over lambda. And we have to know the HC lambda. H means 6.16 10 to the 34 and lambda means 4,400 and C means 10 to 10 to the power 8 and we have done this calculation by calculator. Finally, we have got 2.82 electron volt because we have converted this to the unit electron volt by dividing 1.6 into 10 to 1. Thanks a lot. Please, if you get benefit from this lecture, please like me, comment me, and share this video. And it will boost up my feelings for making a lot of tutorial. Thanks a lot. Assalamualaikum, dear Facebook friends. Now I'll discuss about fourth mathematics numerical problem related to physical optics. Okay, I have drawn this picture and this picture, and there is step and question C. We have to determine things with. Okay, this question C. We'll get a good question, guys. Look at this figure and this figure. And Young's double slit is shown in the figure. The wavelength of the light is 5,500 non-stop. The width of the slit is 0.5 millimeter and the distance is 1 meter. Guys, what do you mean by this sentence and what do you mean by this figure and this figure? There is a sort of difference on this. Anyway, try to understand. This is actually PO is skin, and yeah, question has said the distance 1 meter. This is 1 meter D. This 1 meter D. This is skin, and this is actually S1 S2 distance 0.5 millimeter. 0.5 millimeter. From this is distance is D. And S1 S2 this is incident distance 0.5 millimeter, which has written here 0.5 millimeter. This 0.5 millimeter, this distance, and skin distance 1 meter. This okay, 1 meter D. Yeah, 0.5 here A, guys, and this figure are written for making you understand the fins width, guys. This is fins width. It's dark fins. It's dark fins, and it's bright fins, and width of the fins is delta x. Width of the bright fins delta x. All are equal. Okay, that is delta x, and we have to find out this delta x fins width. For finding out this fin width, we have to apply this formula. Del x equal to lambda g over 2a. Lambda g over 2a. What is lambda? What is g? What is a? We have to know from this figure. Our system has said the wavelength of light is 5,500 Armstrong. Here, lambda is the wavelength of light, which comes from the source S and goes to S1, S2. This is slit, and through this slit light goes, okay, and fall on this screen. Then there is created such type of fins. This fins, well, this is bright fins, this dark fins, this bright fins, this dark fins, this bright fins, and this is the width of bright fins, this is the width of dark fins, this is the width of the, and these are equal. Okay, now that is delta x, and for finding out the delta x, this is the formula, and this is lambda d over 2a. Guys, I have said about lambda. This is the wavelength of light, and I have said about g. This is the distance between skin and slit, and I have said 2a. Here, this 0.5 millimeter slit distance. This is the source. This is slit S1, S2. So this light passes, and light comes from this source. This is a monochromatic source, and from this source light comes, and and it's a clear source. Okay, guys. Now this delta will find out, and we put lambda 5,500 into the minus state, because here Armstrong unit is given. That's why we have converted meter into the minus 10, and g value here 1, and a value here 0.5 millimeter. We have to convert into meter. You know, 1 millimeter into the minus 3 meter. Here meter, this meter, this meter, this meter. Okay, and if you do this calculation by calculator, you will get the 5.5 into 10 to the minus 4 meter. This is actually fins width. It would be dark fins or bright fins. The width of dark fins and bright fins equal. Okay, that is delta x. Our question has said to determine the fringe width of the interface. We have found this fringe width of the interference, and this is the interference pattern. And fringe width, this we have found delta x is lambda d over 2a by the calculator. And we have got a value given lambda when we found this. Okay, d here, this, a here, this. Okay, and lambda, lambda, the wavelength of light is has come from this source, okay, and has gone through the source. All of that is been done. Get these things, guys. That's it today, guys. If you get profit from this, if you get benefit from this tutorial, please like me, comment on this tutorial, and share this. The more you share, the more tutorial I will make. Thanks a lot. Assalamu alaikum, dear Facebook friends. So now I'll do 5 number methods, which is related to current, electricity. Okay, this mathematics is this physics mathematics is related to physics second part. Okay, third chapter, which name is current, electricity. Guys, this circuit I have drawn. What do you mean by this circuit? And question has asked us to find out the equivalent resistance. That means we have to find out equivalent resistance, and different type of resistance, different amount of resistance have been given in the circuit. We can observe that here R1 means 3 ohm, and R2 means 6 ohm, and R3 means 10 ohm, and this 6 volt. And from these two amount of resistance, what can we say? What can we determine? Here, this R2 and R1 are in parallel connection. Guys, in a circuit, we have to consider, we have to think about a parallel connection and series connection. For parallel connection, we have a formula, and for series connection, we have another formula. We have to know those formulas. Guys, look at the circuit. There are R1, R2 resistors, which are 3 ohm and 6 ohm respectively. We have to find out at first the amount of equivalent resistance of R1, R2. Guys, how can we find out the equivalent resistance of R1, R2? By applying a formula for parallel connection. We know the equivalent resistance, 1 over Rp, 1 over Rp equal to 1 over R1, 1 upon R2. Guys, here means parallel connection. From the word parallel connection, we have taken P, 1 over Rp equal to 1 upon R1 plus 1 upon R2. This is the formula for parallel connection. Okay, now we have to put the value 1 upon Rp equal to 1 upon 3 ohm plus 1 upon 6 ohm, and LCM 6 2 plus 1, that means 3 over 6. If we inverse this, that will get Rp equal to 2 ohm. This is equivalent resistance of R1 and R2. Guys, this Rp, that means 2 ohm, will be in series with this R3 resistance. If we draw the figure, it will be like this. Okay, look, here Rp is 2 ohm and here R3 equal to A. Now, just observe this connection is series connection. Okay, and for finding out this equivalent resistance, we have to know the formula for series connection. Do you know the formula of series connection of resistance? I know, which is like R is RP plus RP. This is series connection formula. RS equal to RP over RP plus RP, and RP we have got this, and RP 10. That is total 12 ohm. This is our equivalent resistance. Okay, we have finally got this result. RS equal to RS equal to 12 ohm. This is our equivalent resistance. Guys, we have to observe this circuit and we have to justify this connection is parallel and this connection is series, and you have to know the formula for parallel connection and series connection. From this simple circuit, we can know this these are actually in parallel. By this formula, we have got equation, and finally, we can draw this picture from this R1, R2 from R1, R2 we have got R2 from, and this R3 which circuit has given. That means from this figure we apply this formula. RS is R2 plus is R3, 2 plus 10 equal to 2. This is our this is our answer of C, and the equivalent resistance which we have found. Sure. Thanks a lot. Guys, if you like this tutorial, please like, share, and comment on this. If you comment or share or like this, I will boost up myself, I will boost up my feelings for making video tutorials. The more you share, like, comment, the more tutorials I will make. Thanks a lot. Salam. Dear friends, this is Mohammed Yashid. Today I will discuss about 6-number mathematics. Guys, look at the step you can see, and you can actually understand what does this picture mean. After all, you have to read about the parallel capacity from physics second part book. Okay, from the second chapter, static electricity. Guys, yeah, figure 1 and figure 2 I have given, and figure 1 is big and is smaller. As distance d1 is larger than d2. Guys, yeah, plus features minus features plus features minus features. This is capacitor. What's the name of this capacitor? Its name is parallel capacitor, because this two plates are at parallel state. That's why this called parallel capacitor. And you know the application of capacitor. If you think about the fan, there is a application of capacitor. You know, fan contains capacitor. By that capacitor, it takes energy and it rotates. Okay. This capacitor is a plate capacitor. First capacitor plate area 4 centimeter square, and second capacitor this actually 2 centimeter area of the plate. This plate area 4 centimeter square, and this plate 2 centimeter square. Guys, and distance d1 within 2 charge plus 2 minus 3 for this capacitor, and d2 distance between two plates. Okay, and question C. What is moreover both cases charge plus 2 kilometers. Here 2 kilometers. Here 2 kilometers. 2 kilometers. Both charges are equal. Okay, nice. Question C, and K is 1 here. Actually, dielectric constant here is a question C has asked us to find out the energy stored in the capacitor. This we have to determine. Okay, energy stored in the capacitor. Guys, who are learning physics, and physics is related to matter and energy. This capacitor is matter, and it is storing energy. This type of energy, electrical energy, and we have to find out that that energy stored here. How can we find out that? From a formula we can find out. We know what we know. Storing energy E equal to half QB. This formula we have to know. Okay. This is actually for finding out the storing energy of a capacitor. This formula you have to know. And here Q is charge 2 coulomb and D here given question C. Okay, the potential difference here, B is the potential difference and C is the charge. That means here given that charge Q equal to 2 coulomb. Charge is there, and so his amount is 2 coulomb. And potential difference B equal to was the amount 2 volt. Okay, and potential unit is volt and charge unit is coulomb. Those are given in this STEM, and we have to find out the answer C. The storing energy in the capacitor base. Okay, and by this formula we will find out very easily, very simple. Actually, we have to remember this formula equal to half W. Okay, more of some person write down W equal to half QV. Here charge visible. Just was the amount of charge here. Question has given as for both cases. Charge Q equal to 2 coulomb. That means here 2 coulomb multiple 2 and potential difference. The potential difference. This is potential difference which question has given us to let for first figure. Actually, we are doing mathematics for first figure. Here, potential difference 2 volt. Okay, 2 volt. If we do multiple calculation, just 2 joule. Here, in this joule, this is our required answer. And this amount of energy is stored by this capacitor. And is it clear? Again, I say, guys, two parallel capacitors are shown in the figure below. Two parallel capacitors. This parallel capacitor 1 and parallel capacitor 2. And this plate area 4 centimeter, this plate area 2 centimeter, and both cases charge is 2 coulomb. 2 coulomb. Here it stores 2 coulomb charge. It stores 2 coulomb charge. Between two plates of the first figure is 2 volt. This first figure between two plates, the potential difference is 2 volt. We have to find out the energy stored in the capacitor. How much energy this capacitor is stored? We have to find out the source. We have to find out that. How can we find out that? We have to find out by this formula W of P equal to half QV. Q here just bigger voltage. Just remember this formula and putting the value Q and V, then you can find out actually the amount of storing energy. This is the storing energy by this fast capacitor. Okay, guys, if you get benefit from this lecture, or if you like this, please share. The more you share, the more video tutorial I can make. Thanks a lot. Assalamu alaikum, guys. Now I'll do 7 level mathematics, and STEM is like this. Mr. Shoaib named an engine and claimed that it's a reversible Carnot engine. He claimed that it's a reversible Carnot engine. This engine converts 1/5 of its absorbed heat. This absorbed heat, okay, 1/4 into warm, okay, and rejects rest of the heat. That amount is 300 joule. To sink, okay, this thing, okay, should measure the temperature of the source. This temperature T1 source temperature and sink temperature T50 Kelvin and T10 Kelvin respectively. We have to calculate the temperature of the heat source. This is heat source. Okay, this heat source. Okay, we have to measure that temperature, guys. How can we measure this temperature heat source? Okay, how? Actually, For determining this resource, we have to understand this figure, guys. This figure has been given by the STEM. I have drawn this for making you understand clearly about the resource and sink. Okay, guys, the temperature of fish sauce T1 350 Kelvin, which showed result. Okay, and the T1, this is the fish source, and from this fish source, this engine takes heat, and then this engine rejects to the sink. So we have to have clear concept about sink and resource. From resource engine takes it and to the sink heat engine rejects it. Okay, and finally, the heat engine uses heat to do what? That is W into Q1 minus Q2. W into Q1 minus Q2. Yeah, Q1 is greater than Q2, and T1 is greater than T2. But T1 due to T1 due to resource constant, T2 due to sync is constant. Guys, our target to find out the temperature of the heat source. This T1 we have to find out is the heat source. And question has given as again 1/5 of its absorbed heat into what? This guys, what? That is this W into 1/5 of the absorbed heat, which is absorbed heat. Q1 is absorbed heat. From this source, it is absorbed. That's why Q1 is absorbed heat. And the question has said 1/5 of its absorbed heat into work. This W into Q1 minus Q2. Okay, from this equation, we'll find out calculate the temperature of the heat source. Sorry, yeah, temperature of the heat, not temperature, in the heat of the heat source. Okay, heat of heat source. We have to find out that of the heat source. This we have to find out. How can okay? We know W equal to Q1 minus Q2. Here, the system, the absorbed heat, absorbed heat Q1 equal to we don't know. So we have to find out this. And rejected heat, the rejected heat Q2. This is 300 joule, which question has been asked. This is 300 joule, and work done W equal to this 1/5 of absorbed heat. Okay, we have to find out absorbed heat Q1. Guys, we have got Q1, Q2, and W. By this equation, we will find out Q1. Guys, yeah, W equal to 1/5 Q1 over this is Q1. Q2. Okay. Now Q2 to website Q1 minus Q1 4. Okay, and 4 Q1 Q1 this means 3 Q1 over 4 equal to Q2. Okay, fine. Now we have to find out Q1. We have to find out Q1. Q1 equal to 4 Q2 over 3. Okay, 4 Q2 means 300 and Q3. That means 400. This is our answer. That means here the heat of the heat source Q1 is 400 joule. Right, is our required answer. Q1 where the absorbed heat Q1 again I say Shahid made an engine and he claimed that this engine is a reversible time engine. This engine converts 1/5 of its absorbed heat into work. This line we have to remember. It's very important for doing this in paper. Converts 1/5 of its absorb heat into work and reject heat of to a sink. So 300 joules. So measure the temperature of the source and the sink 350 Kelvin and 310 Kelvin respectively. Guys, for making you understand, I have drawn this figure, and this is heat engine. This is heat engine, which has converted W into T1 minus T2, and here the source T1 and the sink is T2. The engine takes heat from this heat source T1 and rejects heat to heat to the sink. Okay, this sink temperature 303 and this heat source temperature 32. We have to find out the heat of the heat source. This T1 we have to find out from this fluid convert conflict of its absorbed heat into work, where we have written W into T1 minus T2, and from the figure you can see heat engine does work W into T1 minus T2. This equation is very important for doing this practice. W, and we have to understand this W into T1 minus T2. Yeah, W into T1 over 4Q, because question has said 1/5 of its absorption into work T1 minus T2. And finally, to the left, T1 minus T2, we have done this calculation for T1 minus T1, that is T1 over 4 will be T2, cross multiplication 4 T2 and T and as a denominator. That we put the value of Q to 300 joule, which has given, and by calculation we have got here 100, that means 100 times 4 is 400 joule. 400 joule is the heat of this heat source Q1, which question has said behind that. Guys, thanks a lot. If you like this, if you get a benefit from this lecture, please comment, share. The more you comment and share, the more video tutorial I can make. Thanks a lot. Assalamu alaikum.